Very good morning to all of you. So today we are going to discuss one of the important topic, that is different types of chemical reactions, different classification, different organic, actually this is a reaction, different types of organic reactions here. So different types of reactions are, one of them is substitution reaction, addition reaction, and another is elimination reaction and rearrangement reaction. So we will discuss one by one what are different types of reactions: substitution reaction, addition reaction, elimination reaction, and rearrangement reaction. So first we will see here this, what is substitution reaction. The substitution reaction is the one in which one atom replaces one or more atoms or groups are substituted by suitable atoms are called as substitution reactions. For example, we will here take the example: A, B is the name of the substrate, and for example C is the name of the reagent. This will substitute B. As a result of the product will be AC plus B. Clear? So this is how the substitution takes place. But there are actually three types of substitution reactions. So one of them is the electrophilic substitution reaction. So electrophilic substitution reaction actively is a in case of electrophilic substitution reaction, the attacking reagent is electrophile. So you have learned about the what are different electrophiles. So electrophiles are actually the electron deficient centers. They are electron deficient centers, that is they are electron loving because they need electrons. So these electron deficient centers will attack on the electron rich centers. So here is one of the example here. For example, benzene, you know that in case of benzene there are pi bond between carbon and carbon. As a result of these pi electrons, this benzene becomes an electron rich center, and this chlorinium ion acts as an electrophile. This will attack on this benzene, and as a result of which the product will be formed as chlorobenzene plus hydrogen. Clear? But actually what is happening here, you must see that in case of benzene there are here hydrogens present at each carbon atom, as already mentioned. So here the one this electrophile chlorinium ion will replace this hydrogen. That is why it's called as a this is called as a substitution reaction. That is that is hydrogen atom is substituted by this chlorinium ion. That is chlorinium is ion is electrophile. So it acts as electrophile, attacks on this electron rich center. The results in the formation of chlorobenzene, and this hydrogen gets released in the form of H positive ion. Clear? So actually what happens there in the during the reaction, you will see the formation of here the formation will be like this. There are hydrogen, and this is chlorine gets attached to this benzene. As a result, this hydrogen gets knocked out, is in the form of proton. So chlorine get in the the product will be chlorobenzene. As you have seen, the chlorobenzene is formed here. So this is a product chlorobenzene. It means that hydrogen has been replaced by this chlorine. So this is called the substitution reaction. Clear? But you must know that you must show the arrows from electron rich center to that of the electron deficient center. You will never show the arrow like this is wrong, because the arrow already shows arrow is always goes from all arrow always goes from electron rich center towards the electron deficient center. Clear? So reacting product will be the chlorobenzene and proton. So this is called the electrophilic substitution reaction. Similarly, you will say take the another example. So this is a benzene here. The electrophile is nitronium ion. This electron deficient center, and this is electron rich center here. So similarly, you will see there are presence of protons, hydrogens here. So this hydrogen atom gets replaced by this nitronium ion. So this is a presence of results in the formation of nitrobenzene, and this proton gets replaced by this NO2 group. That is why this is called as a substitution, and one atom gets substituted by another atom. So hydrogen gets substituted by NO2. Clear? This is called as a substitution reaction. Similarly, you will see another example. Second type is called a nucleophilic substitution reaction. So here we have discussed about the electrophilic substitution reactions. So we will now discuss the nucleophilic substitution reactions. So in case of nucleophilic substitution reaction, though now the attacking reagent is nucleophile. Nucleophile, these are electron rich centers, so they will attack, they will tend to attack at electron deficient centers. So here is a case when this OH ion, hydroxyl ion, will act as a nucleophile because it is having the lone pair of electrons on oxygen, and as a result of which it will substitute this bromine to form the methyl alcohol plus bromide ion. The actual reaction mechanism is different. It actually, there are two types of this substitution, nucleophilic substitution reaction. One is SN1 reaction, one is SN2 reaction. This is called as unimolecular substitution reaction. This is called as a bimolecular reaction, substitution reaction. Here the rate of reaction depends upon the only one, that is called as a nucleophile, and that is rate of reaction depends upon the substrate, and in this case rate of reaction depends on two molecules, that is nucleophile as well as the substrate. That will you will learn in your higher class in 12th. Clear? So here we will take a simple nucleophilic substitution reaction. How does it work? So here it's actually the nucleophile. This will replace this bromine. Actually what happens is the nucleophile will attack this carbon atom, because carbon and bromine, among carbon and bromine is more electronegative. It gets slightly negative charge, and carbon gets slightly positive charge. So there is some charge separation occur between the carbon and bromine due to polar in nature, as a result of which this electron rich center which will attack at the carbon which is electron deficient center, as the result in the formation of this methyl alcohol, and this bromine gets knocked out in the form of bromide ion. Clear? So this is called as a nucleophilic substitution reaction because the attacking reagent is nucleophile. Clear? Similarly is another type of nucleophilic substitution reaction. This called as a free radical substitution reaction. Here the attacking reagent is actually free radical. So here is a free radical. Attacking reagent is free radical, which takes place at high temperature or in presence of light, in presence of ultraviolet light. So it involves following steps. But this free radical substitution reaction involves the following steps. The first step is that you know that what are free radicals. First step is initiation. Initiation means formation of free radicals. So in presence of light or in presence of heat, high temperature, the free radicals are formed. Free radicals are formed due to the homolysis. This is the bond between chlorine and chlorine gets breakdown, and is called as a homolysis, when each of the participating atom gets each electron. That is one, they gets one electron each. That is why chlorine gets one electron, and this chlorine also gets one electron. So these are called as chlorine free radicals. So actually there occur the generation of free radicals. This step is called as initiation step. In initiation step there occur the generation of free radicals. Clear? So in next step of the same free radical substitution reaction is, so here the propagation occur. Propagation means, for example, here in first step, initiation step, chlorine radicals were generated. So this chlorine radical will attack at the another molecule. For example, here the chlorine radical is attacking this hydrogen atom. So due to which the bond between hydrogen and this methyl group gets broken down as a result of by homolysis. That is, homolysis means each carbon and hydrogen gets one electron each, due to which this hydrogen, you will see here, the hydrogen chlorine radical plus this hydrogen radical will form the bond. The bond, that is actually this bond will form between chlorine and hydrogen. As a result, the HCl is formed. This is the HCl formed between chlorine and hydrogen, because bond involves the pair of electrons. That two electrons result in the formation of bond between chlorine and hydrogen. So chlorine and hydrogen gets result in the formation of HCl, hydrochloric acid. And due to this homolysis, this methyl group, methyl radical is generated here, because it now gets and this unpaired electron, this is called as a methyl radical. So this step of the reaction is called as propagation, because this free radical reaction is now propagated from one molecule to from one free radical to another free radical. So one type of free radical will generate another type of free radicals. For example, here is this was chlorine free radical. No, it generates another type of free radical that is called the methyl free radical. Clear? Similarly, you will see here that this methyl radical will again acts on this chlorine molecule, as a result of which there occur another generation of another free radical that is called as a chlorine radical. But here the CH3 will combine with this Cl, just like as this. You know that CH3 contain one electron, and due to this breaking of chlorine bond, and there is a generation of one chlorine radical also. This chlorine radical will combine with this. As a result, bond is formed between CH3 Cl. So chloromethane is formed, and as well as chlorine radicals are generated here. So this reaction is called as propagation reaction. So propagation reaction, you must remember that in which new radicals are generated. Clear? So after that, there is a last step, is a termination reaction. In termination reaction, you will see that now the free radicals will combine each other. This is two chlorine radicals having each unpaired electrons. So here is the unpaired electron. For the example, this accordingly there is another free radical chlorine. It is having the unpaired electron, and these two unpaired electrons will form the bond between these chlorine atoms. As a result, you will see formation of Cl2. Clear? So it's called termination, because the free radicals are now they get terminated. That is they combine to each other. Clear? So this is the end of the. You will see. You may also remember that there occurred the end of the free radical generation. So these free, for example, there is also the two methyl radicals, CH3 having unpaired electron. Similarly, CH3 having unpaired electron. So they will combine each other to form what? This called as ethane. So C2H6. Clear? Or CH3. Clear? So this is how the termination reaction takes place. So this was all about the free radical substitution reactions. We have discussed the substitution reactions are three types. Depends upon the attacking reagent, whether it is electrophile, whether it is nucleophile, whether it is free radical. So when there is the attacking reagent was electrophile, we say this is called as the electrophilic substitution reaction. When this was a nucleophile, this we say it is a nucleophilic substitution reaction. When the attacking reagent was the free radical, so then we will say it is called as a free radical substitution reaction. So this was one type of reaction, this is called as a substitution reaction. Similarly, we have another type of reaction, this is called as a addition reaction. So addition reactions actually the addition reaction takes place in the organic molecules which are unsaturated in nature. Unsaturated in nature means they contain double or triple bonds. Clear? For example, here we have taken the example here. This is ethene, which contain carbon-carbon double bond. In presence of bromine, it gives ethylene dibromide. So these bromine atoms gets attached to these two carbon atoms across the double bond. So that results in the formation of ethylene dibromide. But this addition reaction is also of three types. Depends upon the attacking reagent, whether the attacking reagent is electrophile, whether the attacking reagent is nucleophile, whether the attacking reagent is what is called as a free radical. So accordingly, we have three types of addition reaction. First reaction is a electrophilic addition reaction. So electrophilic addition reaction means though now addition occur because due to the attacking of the electrophile. So electrophile means electron deficient. So electrophile, for example, electron deficient center, for example, will this will attack to that of the electron rich center. But arrow is direction of arrow is different. That is from the movement of electrons, where the movement electron takes place from electron rich center to that of electron deficient center. Actually the attacking reagent is electrophile. So this is called the electrophilic addition reaction. So we had taken here the example. So this addition reaction takes place across the carbon-carbon double bond or carbon-carbon triple bond. So for example, we have taken the reaction, for example, hydrogen bromide. So this is hydrogen bromide here. Hydrogen bromide. We know that bromine is more electronegative than that of the hydrogen. As a result, the bromine gets slightly negative charge and hydrogen gets slightly positive charge. So there are, you may see there is a polarity occur between two atoms, hydrogen and bromide, and there is a formation of reactive centers. We may say that this proton H positive. No, this will act as a what? This is that acts as electrophile because it is electron deficient. So this electrophile will attack on this carbon-carbon double bond. But what will you will see? You are seeing the direction of arrow is different because actually the double bond across the double bond what happens is that the pi bond will shift toward this carbon, as a result of which this carbon becomes electron rich. So electron rich because due to the electron richness, this will this electrophile will attack at this carbon, due to which there occur the in direction of the arrow is from electron rich center towards the electron deficient center, but attacking reagent is electrophile. So that's why it's called the electrophilic reaction, electrophilic addition reaction, because it occurs the addition occur across the carbon carbon double bond. So actually what happens here, there due to this attacking of the electrophile, this step is very slow, results in the formation of carbocation. So actually in when you see the mechanism of the reaction, you always see the formation of what is called as a what is called as this called as for example, you always see the formation of reactive intermediates. So reaction intermediates may be carbocations, carboanions, carbenes, nitrines. So these are what these are called as a reactive intermediates. So similarly here the formation of carbocation gets generated here. So this is also this reactive intermediate is highly reactive, short lived. So as a result this carbocation, accordingly you have seen that stability of carbocation depends upon the with the group which is attached adjacent to this carbon. So okay, accordingly we have already discussed in the inductive effect that tertiary carbocation is more stable than secondary is more stable than primary. So accordingly there are two it is it may have two SN1 or SN2. Clear? So here let us see here that for example this is that an addition occur across the carbon carbon double bond. So if there is a result formation of this ethyl carbocation, and this bromine gets here released, knocked out in the form of bromide ion. Clear? So it's clear the actual mechanism of the reaction is somehow different, but you only may remember here that the attacking reagent is electrophile. That's why it's called electrophilic addition reaction across the carbon carbon double bond. So carbocation is formed in the first step. This is a slow step, and in the second step what will happen, this carbocation now this bromide ion, the in actual cases there occur now nucleophilic attack. Clear? So this bromide ion will now this will attack on this carbocation, and this setup is very fast and results in the formation of ethyl bromide. So this called as a addition reaction. You will know more about these reactions, different types of in more know about these reactions in your higher classes. So up to this is this enough for you. So similarly, so in case of what is this called as a electrophilic addition reaction. Attacking reagent is electrophile, and you will get first in the first step you will know that there is a formation of carbocation. This is slow step. This is rate determining step. So according the rate of reaction will depend upon this step, though it does not depend upon this first step. So that is why it is called the rate determining step. So in the second reaction, the second step, carbocation will be attacked by this bromide ion, and the resulting product is ethyl bromide. Clear? Second is, this was electrophilic addition reaction. So second is nucleophilic addition reaction. Now the attacking reagent is now nucleophile. Nucleophile means electron rich. The electron rich center will attack on this electron deficient center. So here what will happen here, that let us see here that see here that when the formaldehyde contain carbon double bond to carbon double bond in presence of hydrogen cyanide, we know that due to this hydrogen cyanide is polar in nature, that is hydrogen gets slightly positive charge and cyanide gets slightly negative charge, and due to which you will see that cyanide ion this acts as a nucleophile. So this electron rich center created in the hydrogen cyanide molecule. As a result of this cyanide will act as a nucleophile, because this electron rich, this will attack at that center which is electron deficient center. The electron deficiency, where is the electron deficient center in case of formaldehyde? You will see that carbon and oxygen, among carbon and oxygen is more electronegative, it will carry some negative charge, and positive will get slightly positive charge. Clear? So now there is a formation of electron deficient center. So this electron rich, that is nucleophile, will attack at this carbon which is electron deficient, and results in the formation of this carbon cyanide bond, and this pi bond gets shifted toward this oxygen. Clear? So here the formation of the cyanide will gets attached to this carbon, and clear, and this hydrogen gets out. This hydrogen gets knocked out. So here the formation product, the intermediate, actually this intermediate product here formed. Intermediate product is this, and this further here the H positive ion, in order to stabilize this oxygen, this it will combine with this H positive will combine this oxygen. As a result, there is a formation of cyanohydrin. This is called as a cyanohydrin, because cyanide and hydroxyl ion gets attached to this carbon atom, and these are called as cyanohydrins, which you will discuss in you more about you will know about in more about cyanohydrin you will know in 12th class. So this is called as a cyanohydrin, and this type of cyanohydrin is called as formaldehyde cyanohydrin. Clear? Similarly, another type of addition reaction is free radical addition reaction. The attacking reagent is what? It is a free radical. Now, so free radical reaction, you must remember that in free radical reactions, there's always it always occur in three steps, as already mentioned. First is initiation, second is propagation, and last termination, as already discussed in the above lecture. Clear? So here is the initiation step. Initiation means there is a generation of free radicals. So here, for example, we have taken the peroxide, organic peroxide here taken. In presence of light or in presence of heat, they occur in presence of heat or in presence of light. So this organic peroxide gets cleaved by homolysis, result in the formation of these free radicals. These are called as alkoxide free radicals. So alkoxide free radicals are generated in the first step. This is called the initiation step. Okay, this in second. Similarly, in case of initiation step, you will see here the hydrogen bromide in presence of this OR negative, यानी कि alkoxide free radical, you will see RO we will combine with this hydrogen radical, gives ROH plus bromide radical is also generated here. So accordingly, this is called initiation step. So this is called the propagation. Propagation means that more free radicals will be generated. More different types of free radicals will be generated. Now this bromine will will combine this carbon. Clear. So as a result of which you will see CH2Br. But when there occur the homolysis of this bond, as one carbon gets one electron, one carbon gets one electron. So this carbon gets another, this carbon gets three electron. That's the unpaired electron. That's why new type of free radical is generated here. So similarly, so this type of reaction, in this setup, this called as a propagation setup, because new free radicals are generated here. Similarly, in case of last step, you will see there is a termination setup in free radical addition reaction. So in termination setup, you will see now these free radicals, now they will combine to each other, result in the formation of stable product that is called the bromine. So this is a stabilization setup. Now the free radicals get a sum up. Clear. This is a final step while these free radicals get stopped to grow more. Clear. So this is we have today we have discussed different types of reactions. Mostly we have discussed substitution reaction and addition reaction. The substitution reaction are three types depending upon the attacking reagent, that is electrophilic, nucleophilic, and free radical substitution reaction. Similarly, we have discussed addition reaction. Addition reaction is also three types. Here is it is electrophilic addition, nucleophilic addition, and free radical addition reaction. So this was all about today's topic. Hope you understand. Have a nice day.